French literature. It's that camus, that's the existentialism. You know, life sucks and then you die. And so we have a motto, people. We have a motto on the sundial. 2 worlds, 1 sun. Shadows on Mars must needs be cast by light from the same life-giving star as shadows on Earth. It's cool. It's inspirational. It's something to think about for. It's cool. And the red dot represents Mars in its orbit, and the Earth is blue in its orbit, and the rings are different values, different graynesses, graith. And it has the word Mars in 16 other languages besides English, kind of cool. And the flight spare, the leftover Mars dial from the Spirit and Opportunity rovers, is going to leave the Earth a week from Friday. A week from Saturday. It's been postponed 1 day. It's going to go on the Mars Science Laboratory, MSL, whose whimsical happy name is Curiosity. The Curiosity rover will leave, and there were some political issues. I was not involved. I did what I could. But the motto on that one is, to Mars to explore. I want to reassure you, if any of you are old enough to vote, I think most of you, taxpayers, all one way or another, yes, we're all in this. I did do some work on this thing. I mean, I look like this one, I did do some work. I did the vibration analysis on the gnomon, the thing that sticks up. By the way, the thing is this big. This is a little bit of an exaggeration. Wow. Science guy ends career with joke. No. It's all good. Telephone poles. Things should be sundials. Anyway, the thing is made of aircraft aluminum was indestructible. I did the analysis to make sure if it had come loose or broken on the way to Mars and bounced around in $1 electronics, Uncle Bill with his kookball sundial thing would have been bad. Would have been very bad. But somebody did send me this picture. And whoever did it, if you're here, nicely done. Thank you. There was a full, if I may, comedy beat where I saw my life pass before my eyes. But it turned out it was April 1st. Oh, you crazy kids. Your Photoshop, you're so nutty. Oh. You did get me, whoever did it. It's really good. So, nicely done. Now, let's say that this picture of the sun represents the sun. If I were to ask you in round terms how far the Earth is from the sun, what would you say? You'd say a bunch of big numbers, but you could say just one astronomical unit, and that's an astronomical word for the average distance from the Earth to the sun. And it's easy to remember because if someone's trying to get your attention, what do they say? AU! So it's 1 AU. And then Mars, by comparison, is 2.5 times as far. Mars is 2.5 AU from the sun. So you would expect, I think, being 2.5 times as far away, you would expect Mars to be colder. And it is indeed kooky cold. It's so cold. Wow. It's so cold. How cold is it? Yes, I was a little worried. Anyway, the poles are not just ice. They're dry ice, or frozen carbon dioxide. Very cold. And then you would expect, I hope, that Mercury, which is much closer to the sun, just 40% of the distance to the sun, 0.48, is much hotter. Yes. And Venus, 70% as close, you would expect to be hot also. Mercury is too hot, Venus is way too hot, Mars is too cold, and Earth is just right. But here's the thing, peoples. Venus being 30% closer, you'd expect it to be somewhat hotter. For you inverse square law buffs, you'd expect it to be sort of twice as hot. 7 squared is 49%, so it's twice as hot, something like that. But turns out it's much, much hotter than that. If you go to the surface of Venus, which a couple spacecraft have, these were Russians' Federal Space Agency, or in those days, Soviet Space Agency, went to the surface of Venus, and the spacecraft lasted less than an hour because it's so freaking hot. 90 times the atmospheric pressure that we have on Earth. And it's so hot on Venus that lead would be molten. Lead would be liquid. We'd have liquid. Yeah. And I hope you all have played this game where you can't like step on the carpet because it's like lava. And you can't drink the water in the sink because that's like acid. And so you have to get across the kitchen, on chairs and things like that. They're wooden chairs. That's not fully explained. But the thing is, on Venus, it's so hot. How hot is it? It not only rains sulfuric acid. Sulfuric acid! Not only that, it doesn't hit the ground because the surface is so hot it evaporates before it gets down there. By Western reckoning, the traditional reckoning, Venus is like hell. It really is, but it's only a little bit, in a sense, in the astronomical sense, only a little bit closer to the sun. If you go to Mars, on the other hand, it is cold. It's on a summer day at the equator, it's 0 right here, freezing, 32 Fahrenheit, back in the old 18th century expression. Here it's about 20 below, and here it's about 40 below Celsius, 40 below Fahrenheit. It's cold, but it's not that much farther. And the reason is, on Mars, if there are any of them, they hardly have any atmosphere. On the Earth, when I was growing up, we would say the Earth's atmosphere was 1,000 millibars. Millibar is an old unit that's very nice. It's a thousandth of a bar, and everybody knows what a bar is. But on Mars, it's 7 millibars. So it's not even 1% of the Earth's atmospheric pressure. By the way, I'm Mr. System International. Like anybody. Millibars has a 10 to the 5th, has 100,000 in it. So it's no longer a true System International unit, SI unit. So the same unit expressed in modern terms is a hectopascal. So Pascal, if you're storing one of this, is only a Newton over a square meter. It's not much. A Newton is an old trick. An apple weighs about a Newton. So if you spread an apple out over a whole meter, it's not a lot of No, so hectopascal. So my proposal is, you guys, as you come of age, maybe we can call them heps. So these data are from the Sojourner rover, which landed on Mars in 1996. So notice, carbon dioxide is 95% of the Martian atmosphere. 95%. And without even that, the Mars would be really cold, not just crazy cold, it'd be like really crazy cold. The Earth, 0.03% carbon dioxide. 0.03%. Now, if you're going along with us and you're savvy exponent-wise, 0.03% is the same as 300 parts per million. It's the same number. 0.03%, 300 parts per million. All of you in this room, all of you, were alive, rounding to 1 digit, when that number changed from 0.03 to 0.04. And that tiny change in what seems like an insignificant number of who much cares about a gas in the Earth's atmosphere is changing the world. And that's what I want you guys to do, is change the world. I want you to